Welcome back to Better Automated Acceptance Testing with Serenity Screenplay. I'm John Ferguson Smart and I'm going to be your guide through this tour of Serenity Screenplay, the screenplay pattern, and some of the more advanced aspects of how you make the screenplay pattern work. In the last episode, we looked at the overall structure of Screenplay and we started to see how you could write some simple tests. In this episode, we're going to be looking at one thing that you really can't get away with. It's questions. Now, in the last episode, we looked at tasks, business tasks, actions, how you could encapsulate business logic in a reusable component that you can share between actors and even between projects. An action is something that an actor performs to achieve a goal. But the other side of the coin is that the actor needs to be able to query the system to ask whether the application is in the state that she expects it to be in. And that's what we do with questions. Questions are a little bit like actions, but they are for querying the system, not doing something with the system. So in the next 10-15 minutes, we'll be having a look at what screenplay questions are in practice. We'll be having a look at some real code and converting the code that we did in the last episode to a more idiomatic screenplay test that uses questions. We'll be looking at Humcrest matches again. We'll be seeing the relationship between Serenity screenplay questions and Humcrest matches and how they all tie together. And we'll be having a look at how the questions and the outcomes of the questions appear in the Serenity reports and how you can fine-tune this. Let's go back to the project we were looking at in the previous episode. Now we can see here that we have an actor, Petra, who is Petra the pet owner. She's got a pet cat called Ginger, and there's a hotel called Pet Hotel California. Now, Petra attempts to check her pet in, and here we do an assert that Pet Hotel Get Pets has item Ginger. Now, if you remember how this was rendered as a Serenity report, you remember we had Petra books her pet cat into the hotel, which is basically this. Petra books her pet cat into a hotel. Then we reported on the business action, the steps that Petra had to do, or the high-level tasks she had to accomplish. And we have here Petra the pet owner checks a cat called Ginger into the hotel. That corresponds to Petra's attempt to. Now, you'll notice that for the assert that, we don't have anything. We don't have a line here saying what we should expect, what Petra expects as the successful outcome of this test. And that's a shame because in a living documentation style approach, we like our tests to explain what they do and document not only what happens during the test, but how those tests are verified. And that's where questions can help. We can use questions to verify the state, the outcome of the system, but also to report on our expectations. And the syntax is somewhat similar to the Humcrest syntax. Rather than saying, I'll leave the Humcrest syntax just so we compare. Rather than saying assert that, we talk about something that Petra should do. What should Petra see, or what should Petra note? We say that Petra should, and what should you do? She should see that. And now we're going to invent a question. We're going to think of what we'd actually like to ask of the system. What we really want to know is Ginger the cat in the list of registered guests for this hotel? So we might write something like, see that the registered guests in Pet Hotel. And then we can just use has item as we would in a Humcrest matcher, has item Ginger. Now see that from the given when then class from Screenplay. And then we have the registered guests. Let's see what that is. Let's create a class called the registered guest class. Now questions are like tasks. They're reusable across projects. Now questions are like tasks. They're a class that is focused on doing one thing and one thing only. So it's the single responsibility principle in action. All the question does is answers a query about the state of the system and returns an object of a given type. So we say that the question, this registered guest is a question of type, and what do we want to answer? We want it to return a list of pets. So the goal of this class is to return the list of pets that it finds registered in a given hotel. Now I can see here we're missing a method. Just like the task or the performable has the perform as, a question has an answered by. So it's all about the actor. It's answered by the actor. Now, in this scenario, this is a fairly simple one, an overly simple one really, because the actor doesn't actually do very much. We'll see later on when you do web tests or tests with a REST API, which is more realistic, the actor will have her own browser or her own connection with a RESTful service. So the actor has a much more important role to play in this querying of the system. But for this, at this stage, all we're really interested in is querying a hotel that we pass in, and that can happen too. So we can have question in the hotel. And we're looking for a question, we can just make this. We know what sort of question we want. We want a question that returns a list of pets. So we're going to return a new instance of this class. We're going to pass in the pet hotel because the question needs a pet hotel to query it. And I'm going to implement this field. We're going to need a field for the pet hotel to remember it. And now it's all we need to do is in the answered by method, we say pet hotel get pets. That will do nicely. And the way this works is this little object might seem a little bit complicated, but let's break it down. We're creating a new pet hotel, a new registered guests question here using a builder method, a very simple builder approach. So it's the registered guest dot in pet hotel will give us an instance of the pet hotel, the registered guest for that pet hotel. And then when the time comes, if we go back to our code, when Serenity or when Petra checks whether she sees that against the current state of the system, the registered guests object will be called. So it's not called here when it's instantiated. It's called when Petra calls the should method. So that's quite a subtle but important difference. This is why the instantiation happens here. We set up the registered guest question here, but we actually do the questioning here because the system might be in a different state at that point. So now we can remove this, and let's run it again and see what happens. See what happens to our test report. Now I can see the test passes, and I'm going to update this. Now we can see the test passes. I'm going to update the browser. And you'll notice we have then the registered guest should be a collection containing a cat called Ginger. So Serenity has had a look at our test result. Petra should see that the registered guests has item Ginger. It's basically derived the name of the registered guests and combine that with the matcher. Should be a collection containing a cat called Ginger. Now, with pretty much no reporting code at all, we've described the expectation of the system, expectation of this test about the system. So this is really in the spirit of what we call self-documenting code and living documentation. There's one last thing I want to show you with questions. If you remember in the report we had this statement, then the registered guest should be a collection containing a cat called Ginger. The registered guest comes from the name of our question class. But what if that question class is not really what we want? What if we want something a little bit more fine-tuned? In that case, we can use the subject annotation. And rather than defaulting to the name of the class, we can give it a more complete name or a more specific name. For instance, we might say the pets in the hotel. Let's see what happens when we run the test now. We have the registered guest in Pet Hotel. Now we're going to run the test again. So I'm running the test, it's completed. If I refresh this page, we have then the pets in the hotel should be a collection containing a cat called Ginger. This allows us to have both a nice, fluid, readable statement in the question and also a readable statement in the report, because the structure of the report is not quite the same. Sometimes we need to be able to distinguish between the two. And this, again, is all in the spirit of making our documentation, our tests are the documentation, and the documentation produced by the tests should need a strict minimum of extra information to be useful. And that, in a nutshell, is what we try and do with the questions. This is John Smart signing out until next time.